Hello, my name is Todd Nelson. I'm the manager of signal chain module development at Linear Technology. Today I'm going to show you how to match a signal chain to a high-speed ADC input. In any high-frequency signal chain like communication receivers or a spectrum analyzer, there is a high-frequency portion of the design and a baseband section of the design where the signal is converted to the digital domain. The two portions of the design are stitched together at the ADC inputs. In the RF domain, components along the signal chain require matching if the next component has a different impedance. But matching the end of a signal chain to the front of an ADC is not so simple. The traditional way to approach the problem is to measure the input impedance of an ADC on a Smith chart. Here's the input impedance of a 16-bit ADC sampling at 130 megasamples per second. You can see that the resistance varies with frequency and the complex impedance is capacitive, and that it rotates. What is not shown here is the current pulse that results from the switching action of the ADC's sample and hold. The other thing to remember is that your matching network will also be part of an anti-aliasing filter. So you need to do several things. Settle within half a clock cycle after the current pulse. Design a filter that meets the requirements and not load down the amplifier so much that it adds distortion, and match over the entire frequency range of operation. You've also got to balance the layout to reduce second-order distortion and keep it tight so that you reduce reflections. Certainly you may have enough experience to do this, and we would help you anyway, but that's not the easy way. And you probably have equally important things to do. Here is the simple way. The simple way is to find an ADC with resistive inputs and none of the switching transients, yet all of the speed and performance of the pipeline converters. The LTM 9001 gives you exactly that. It includes the amplifier, the anti-aliasing filter, and it also happens to include the reference and bypass caps, since the layout of these caps also reflects performance. For this particular version, the input impedance is a nice stable 200 ohms differential, and it stays that way all the way past 100 megahertz. The RF guys love 50 ohms or any multiple of that, and they can match that in their sleep. So it's that easy. The matching is simple. We've taken away the risk of problems due to layout. We have versions with different gain, different filtering, different sampling rates. And if you don't find exactly what you need, we can probably make another one for you really quickly. We're just trying to make your job a little easier. For more information, visit www.linear.com. Thank you.